Okay, so we are now going to start talking about trigonometry in the coordinate plane. Okay, so trigonometry obviously is Sohcahtoa, which will come in handy in a little bit. But for right now, you're basically just going to be thinking about what happens when I have a sine or a cosine or a tangent value as I rotate around the unit circle. Remember, you're talking about starting with a rotation here at 0. As I rotate to the top, this is 90, this is 180, this is 270, this is 360. If you remember, points on the unit circle are cosine comma sine. So you have to think about if I graph something that goes right and up, that's a positive cosine and a positive sine. That means I end up in the quadrant where things are all positive, okay? Even tangent will be positive when I take that sine over that cosine. In the second quadrant, I'm going left and up. So that's a negative cosine and a positive sine. That's why we say this is the S quadrant, because only sine is positive. In this quadrant, cosine is negative and tangent is negative. Okay, so all positive, only sine positive. In the third quadrant, when I go left and down, that's a negative cosine and a negative sine. This is going to be a place where I have only a positive tangent. So cosine is going to be negative, and sine is going to be negative. And when I divide them, that makes a positive tangent. And finally, when I graph something that goes right and down, that makes a positive cosine. That means because I'm going down, sine is negative, and tangent is also negative. So what we're going to do right now is we're going to just be locating where an angle falls in a quadrant based on given information. So it says use the given information to state what quadrant each angle terminates in. I should remind you this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, because that's the way we're going to be identifying what the quadrant is that it falls in, okay? And you're going to use this Astc chart to figure it out. So I'm going to make an Astc chart. Okay, this given information is going to tell me when things are positive or negative. So sine is positive and tangent is negative. So there's only going to be 2 quadrants that satisfy each of these characteristics. Sine is positive. Sine is positive in the all quadrant and the sine quadrant. That means you're not going to have an answer that falls in either the third or the fourth quadrant because, again, sine has to be positive. In these 2 quadrants, in which case is tangent also negative. This is all positive, this is only sine positive, so your answer has to be this second quadrant. Okay, so quadrant 2, that's where tangent is negative and sine is positive. Okay, so we do this again. Astc, okay, you want to get used to that because you're going to need that for exact values. Cosine is positive, tangent is positive. So where is cosine positive? Cosine is positive in all and the cosine quadrant. So it can't be in the second or the third. Okay, of these quadrants, where is tangent also positive in the all quadrant? So that's why the answer is quadrant 1. Okay, number 3 gets a little tricky, but that's only because you have to do like a little bit of some basic arithmetic to be able to get all of the given information. So this is telling me that cosine is positive. So I know that I have to be in the all quadrant or the cosine quadrant. So it's got to be one of these 2. So now let's take a look at the next thing. I know cosine is positive. I'm seeing that the product of them comes out to be negative. The only way to multiply to a negative is to have 2 things that have opposite signs. So multiplying a negative times a positive is what makes this a negative, and that's why this has to be a negative sign. So where is cosine positive but sine is negative? That would be the 4th quadrant, and that's why the answer is choice 4. And then finally, last but not least, I know you see some actual exact values of the sine in this particular case. It really does not matter. This could be literally the sine of negative 125, which is impossible, but all you have to really focus on is the fact that sine is negative. Sine is negative and tangent is positive. So sine is negative in the T and C quadrants because sine is positive in the A and S, whereas tangent positive in the 3rd quadrant, so your answer is the 3rd quadrant. All right, so getting into beginning of trigonometry. So I know you think of geometry as Sohcahtoa, and while that is true, that is only for right triangles. And we are going to talk about right triangles, specifically special right triangles, but there is more to trig than just Sohcahtoa. When you're talking about trigonometry in the coordinate plane, one of the biggest places that you have to pay attention to is the unit circle. That's going to be where we're going to get a large number of our exact values. Okay, so what makes the unit circle special? The unit circle is a circle with a radius of 1. So if I were to put some points on this circle, this would be the point, for example, like 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, why is that important? Well, when we think about trigonometry in the unit circle, we think of things as like an angle of rotation. So for example, on the right-hand side, that's where we would start with a rotation of 0 degrees. Okay, as I move along, this maybe would be a rotation of 30, 60. Eventually, as I got to the top, from this point on the right, I would have rotated this side maybe 90 degrees. So that's why we would consider the top to be 90. As I continue rotating from where I started on the right to getting all the way to the left, that would be a rotation of 180 degrees. Then I go to the bottom, that would be 270 degrees, and then finally 360 degrees. So if I asked you to give me an angle of 135, how would you represent that? That would be an angle that would fall somewhere between 90 and 180. So the way that I would draw an angle of 135 is I would draw it over here, because as I rotate from the positive x-axis to that point, I've rotated a total of 135 degrees. Okay? So that's one portion of things that you have to remember about the unit circle. Notice the direction I'm rotating. I'm starting here and I'm going to the left. This is is counterclockwise. This is the direction of a positive rotation. If for some reason somebody gave us a negative angle, that means a negative rotation. You either just add 360 to it or minus 360 to turn it into a positive angle between 0 and 360, and then it becomes a usable angle like 135. Okay, so then we get to these points that are on the unit circle, and that's a large focus of today's lesson. Points on the unit circle take the form cosine, sine. You know the pharmacy CVS? CVS. Think of the V like your comma in between your two coordinates. This is to remind you that your x coordinate is cosine, your y coordinate is sine. So for example, if you wanted the sine of 360, that means that you're going to get the y value of the coordinate of 360, and that comes out to be 0. At the top, cosine, sine. Cosine of 90 is 0. On the left, sine of 180 is 0. You see what I'm saying? You're just going to use the points on the unit circle in this order, cosine, sine. Okay? And just one extra thing for like notation-wise, top right-hand corner is quadrant 1. As I rotate to the left, that becomes quadrant 2, quadrant 3, and quadrant 4. These are just important things you're going to have to make sure you memorize along with the special right triangles, and I'll keep repeating them at the start of many of the lessons that we do in this unit. So given the point 1/2, radical 3/2, which is on the unit circle, that's key wording that's important because that tells you that you can use this coordinate pair as CVS, cosine, sine. This means that the cosine of that theta, wherever that theta happens to be, is 1/2. The sine of theta is radical 3/2. The tangent is sine over cosine. Okay, so this is an identity you're going to have to memorize. Tangent is sine over cosine. And if I take my sine value, rad 3/2, divide by my cosine value, which is 1/2, those 2's will cancel, and I'll be left with radical 3/1, which is really just radical 3. Okay, so that's how you get your sine, your cosine, and tangent. Notice I don't have any triangles here. I'm specifically getting it just from these points on the unit circle. So take a look at example 2. Given the diagram below on the unit circle, state the lengths that represent sine, cosine, and tangent. All right, look at this point D. Okay, remember that point D is a point that's on the unit circle. That means that coordinate is cosine theta, sine theta, where theta is our reference angle with regard to the x-axis. If I needed to plot that point, let's say that was the point like 2, 3 or something, I'd be going right x units, up y units. In this case, because it's cosine, sine, I'm going right cosine theta units. I'm going up sine theta units. So that means the length OA, or AO, represents cosine theta. The length AD, or DA, represents sine theta. And then tangent's a little weird. This pulls a little something back from geometry that you had done before. You know in geometry when you have a tangent that just touches a circle at one point, if I extend this line CB, that would be a line that would only brush that circle at one point. So this length CB, that's the length that represents the tangent of theta. That's not really going to come up all that often. I think the sine and the cosine one will be a little bit more important. But again, the main idea of this part of the lesson is to remember a point on the unit circle takes the form cosine, sine. All right, so special right triangles. Special right triangles are the other place that you're going to get any of your exact values from. Technically, there are only two of them, 45, 45, 90, and 30, 60, 90, but I like to draw the 30 and the 60 ones separate, just so that we can do our labels, our opposite, adjacent, hypotenuse, separate for the 30-degree angle and the 60-degree angle. So to be able to use Sohcahtoa, which is what we're going to use with these right triangles, first of all, you need to memorize your sides. For the 45, 45, 90, it's 1, 1, and radical 2. This is my opposite, this is my adjacent, this is the hypotenuse. For the 30, 60, 90, what you want to do to remember the sides of this, think 1, 2, 3. Always across from 30 is 1, hypotenuse is 2, other side is 3, but it has to be a radical 3 so that it's not bigger than my hypotenuse. And once again, label opposite, adjacent, hypotenuse. And then last but not least, across from 60, this is technically a 30 up here. Across from 30 is 1, 1, 2, 3, and again, it has to be a radical 3. This is my opposite, adjacent, hypotenuse. Okay, we memorized these two triangles. Now you have the largest chunk of where most of your exact values are going to come from. They're either going to be points in the unit circle, like these 1s and 0s, or they're going to come back to being something like the sine of 45, or the cosine of 30, or the sine of 60, or the tangent of 30, or something like that. So now we're going to kind of put a little bit of both of things put together. In the diagram below of the unit circle, state the coordinates of point B. Okay, so notice that to get to point B, we rotated 60 degrees. Okay, so this point B is going to be a point that's on the unit circle with a reference angle of 60. Remember, CVS means that this is really going to be cosine 60, comma, sine 60. And now we're going to find out what these exact values come out to be. We're making this whole coordinate pair. All right, cosine of 60. Here is 60. Cosine is adjacent over hypotenuse, so that would be 1/2. And then the sine of 60 is going to be opposite over hypotenuse, so radical 3/2. And that is the coordinate pair that represents point B, a point on the unit circle that takes the form CVS, that we got its exact values from the special right triangle. So you need to have these memorized along with your unit circle memorized. Okay, so now we're going to start getting into exact trig values. Okay, so it's important that you understand that all of your exact values come from either the unit circle or the special right triangles. That's why you have to make sure that you memorize this unit circle and these special right triangles. Okay, on the unit circle, remember the radius is 1, so I have these points at 0 and 90 and 180 and 270, and also 0 is 360. So if I want to know the sine or the cosine or the tangent of any of these values, they come from these points. Remember that points on the unit circle are CVS, cosine, comma, sine. So if I want a cosine or sine of any of these exact values, this is where you're going to get this from, the points on the unit circle. Okay? When we start getting into exact values of things like 45 and 30 and 60, that's when you're going to be using your special right triangles along with Sohcahtoa. Okay? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, remember for the 45, 45, 90, the sides are 1, 1, and radical 2. Make sure that you label your sides properly. For the 30, 60, 90, I would always start across in the 30 and then make that a 1. Go ahead, hypotenuse is 2, other side is 3, but it can't be bigger than the hypotenuse, so it's radical 3. Okay, for the one that's the 60, technically there's a 30 up here, so I start across from that, that's a 1, hypotenuse is 2, other side is radical 3. Okay, and again, make sure you label your stuff correctly, opposite, adjacent, hypotenuse. So finding each exact value, again, going to come from either these points or the special right triangles. If I'm just given a triangle that, let's say, isn't, one of these special ones on the coordinate plane, let's say I'm just given a triangle just to practice. Remember that sine of theta equals opposite over hypotenuse. Okay, so the sine of theta in this case is going to be the opposite, which is this side right here. This is my hypotenuse. This was my adjacent. It's just going to be opposite over hypotenuse, 5/13. Okay, it's just a ratio between two sides. The cosine of 60, okay, 60 is my reference angle. Cosine is adjacent over hypotenuse. So if I go to 60, my adjacent over my hypotenuse is 1/2, and then I'm done. If I need something like the sine of 90, I know that this has 90s in these triangles, but 90 is actually one of those quadrant angles. So what you're going to do for the sine of 90 is you're going to not use Sohcahtoa because you're not dealing with a triangle. You're going to go to that point on the unit circle, and you're going to go to the sine coordinate, which is the y coordinate, and you're going to get that y value. Okay, so the sine of 90 is just 1. Okay, if I needed cosine of 180, I would do the same thing. Go to 180, go to the x value, and that's my cosine of 180. Finally, last but not least, tangent of 30. Okay, here's my 30. Tangent of theta is opposite over adjacent. So according to 30, my opposite is 1, my adjacent is radical 3. I can't leave a radical unrationalized. I can't leave, meaning I can't leave a radical in the denominator. So I'm going to rationalize this by timesing the top and bottom by radical 3. So this becomes radical 3 over regular 3, and that's the value for the tangent of 30. So once again, it's super important you memorize these two diagrams. All of your exact values are going to come from the points on the unit circle or these special right triangles.